Trigonometric ratios of special angles or specific angles is our next topic. Now, what are the angles that are specific, or what are the angles whose values we should be knowing by heart? We should be able to memorize it. Let us see what are those angles. Around a point, you know the angle is 360 degree. So, if you have a point and you start from here and it goes on like this till we reaches, we have got 360 degree. Okay. Now, at this particular point, if I draw two lines which are intersecting each other, you know that this 360 degree is divided into four parts. Now, this looks like a graph, okay, where there is an x-axis and there is a y-axis. So, I can say that this is from 0 degree to 90 degree, this is from 90 to 180, this is 180 to 270, and again this is from 270 to 360 degree. Okay. As I told earlier, we are now talking only about acute angle. So what is acute angle? Below 90 degree. So we are only talking about angles in this particular part, or this is a quadrant of a circle. So we are talking only about the first quadrant of a circle. Okay. Now, between 0 and 90, what are the angles whose values you should be knowing about is what we are going to talk about next. 0 degree and 90 degree, obviously the start point and the end point is important. So 0 degree and 90 degree are two specific angles that we have to be careful about, or we have to memorize the values. Now, their half, the middle of them, which is a 45 degree. Okay. Now, when you were in grade 7, you learned about construction of specific angles. Which are the angles you learned? You learned about 30 degree and you learned about 60 degree, obviously 90 degree and 45 degree. So, we are bothered about 30 degree and we are bothered about 60 degree, and this is our 45 degree. Okay. These are the angles whose values of trigonometric ratio values we should be aware about. Now, when we are going to higher classes, we also need to know about a 15 degree. We also need to know about a 75 degree. But for the time being, you don't have to know about the 15 and the 75. All you need to know about is 0, 30, 45, 60 and 90. Now, again I am telling you, you will be finding so many ways in which to remember these values. You can choose whichever method works for you. The only thing that matters is that value should be there inside your head when you are going to write the examination. Okay. Now, let us see how we can get each one of those values. Let us start with 0 degree. Let us find out the trigonometric ratios for 0 degree. I have a triangle over here where it is right angled at B. I am trying to find the trigonometric ratios of the angle A when angle A becomes 0 degree. Now, technically speaking, practically speaking, when angle A becomes 0, what happens? What happens is that the triangle collapses. There is no triangle anymore. You need to have some amount of angle over here. Correct? Now, the angle of A being 0 degree is an approximation. So, a value which is very close to 0 is our idea. So, we are telling it as a 0 degree, like we do an approximation like this. Okay. Suppose the value is 0.000000000. Let it go on and on. But still there is an angle. But this value can be approximated to 0. Correct. So, we are finding out the value of the trigonometric ratios for 0 degree angle. Now, let us see how we are going to get it. Now, what happens? Suppose this angle has got a particular value. Let it be a 45 degree or a 35 degree, whatever be it. If I am bringing the hypotenuse down, AC is going down, what happens? The angle reduces. Again, if I am bringing the hypotenuse down, the angle again further reduces. It goes till when it is 0 means this particular hypotenuse, this BC is going on reducing. This particular AC actually falls into, BC is something like this, then it actually falls into AB, which means that as far as the angle A is concerned, the opposite side BC does not exist. BC becomes a 0. Correct? So, when angle A becomes a 0, BC becomes a 0. And what happens to the adjacent side AB and the hypotenuse? The adjacent side AB and the hypotenuse collapses into the same line. Okay, so I can say that the adjacent side AB is equal to AC, which is the hypotenuse. So when angle A from a particular value, it goes on reducing and falls over here, so that this particular angle becomes a 0, opposite side becomes a 0, and the adjacent side and the hypotenuse, they are equal. Now what happens to the trigonometric angles? Sine 0 is opposite side by adjacent side, so opposite side by hypotenuse, opposite side has become a 0. So opposite side by hypotenuse AC, it becomes a 0. So sine 0 is a 0. What happens to cos 0? Adjacent side and the hypotenuse have become same in length, which means AB by AC is the same as now AC by AC. So this is equal to 1. So sine 0 is a 0, but cos 0 is a 1. Are you guys clear with the explanation that I have provided? One thing you need to remember in the case of 0 and 90 degree is that both are approximations. They are not practical. It's not practically possible, as I told you, to make an angle into a 0 degree. So the triangle will not exist. So these are approximations. Still, if cos 0 somebody asks you, the value is a 1 and sine 0 is a 0. Now let us talk about the 90 degree values. Before we move on to the trigonometric ratios of 90 degree, we have found out only the trigonometric values of sine 0 and cos 0. We forgot about tan 0, cosec 0, sec 0, etc. So let me do that also. So we know sine 0 is equal to 0, cos 0 is equal to 1, tan 0 is sine 0 by cos 0, which is 0 by 1, which is 0, cosec 0, cosec 0 is actually 1 by sine 0. Correct, which is 1 by 0, which is undefined, or you can say it is infinity. Okay, so cosec 0 and tan 0, they are not defined. Now, tan 0 is a 0, cosec 0 is not defined. Now, sec 0 is 1 by 1, which is a 1. Now, what is a cot 0? Is again 1 by tan 0, which is again undefined. So once you find sine 0 and cos 0, the remaining values you can automatically find, and you can see that tan 0 is a 0, but cosec 0 is undefined, cot 0 is undefined, but sec 0 is a 1 because cos 0 is a 1. Okay, now let us move on to the 90 degree angle. ABC is our triangle, B right angle at B. Now A, in order to make, we are bothered about the angle A. So in order to make angle A into 90 degree, what should we do? If this is our triangle and this is right angle at B, now angle A is bigger. What did I do? I am bringing A closer to B so that my angle A becomes bigger and moves closer to 90 degree. So at a point where this is BC and this is A, my angle A is much bigger than what it was over here. Okay, this is not 90, this is angle A, this is 90. This angle is bigger than this angle. Now the more I am moving close to angle B, the line becomes straighter and angle A becomes bigger. So very close to the point B, angle A is almost 90 degree. Now again, practically speaking, angle A cannot be exactly 90 degree because there will be no triangle then. But it can get really close to angle B. So we can approximate angle A as a 90 degree. Now let us see what happens to the opposite side and the adjacent side. Now at this point, again if angle A moves closer to angle B, you can see that AB, it collapses. And AC falls into BC so that BC becomes approximately equal to AC and AB collapses. Now let us find out the trigonometric values. Sine 90. Now my sine A becomes sine 90, which is opposite side by hypotenuse. Now opposite side and hypotenuse have become almost the same value. So my sine 90 will become a 1. What will happen to cos 90? Cos 90 is the adjacent side by hypotenuse. my adjacent side has collapsed and it has almost become a 0. So my cos 90 becomes a 0. You can see that this is exactly the ulta values for 0 degree. Sin 0 is a 0 but sin 90 is a 1. Cos 0 is a 1 but cos 90 is a 0. I hope you are clear with this. So if you want me to explain again, you can drop a comment in the comment box below, or you can personally ask me for my help in understanding this particular concept. But always understand both of these are approximations and not exact values. So I have a sin 90 as a 1 and cos 90 as a 0. Now can I write tan 90, which is sin 90 by cos 90, which is again undefined or infinity? Now I have got cosec 90, which is 1 by sin 90, which is 1 by 1, which is a 1. Now obviously sec 90 will now be undefined because the cos 90 value is a 0. Now I have got cot 90, which is cos 90 by sin 90, which is a 0. Sorry, not 0 degree, it's a 0. Okay. Now once you find the sin and the cos value, the remaining values just fall into place, dividing or taking the reciprocal. Fine. Now let us find the 0 degree and 90 degree we are done. Now let us see the value of 45 degree. You have a triangle ABC which is right angled at B and you have got angle A as 45. Now you need to find the values of sin 45, cos 45 and the remaining trigonometric ratios of 45. Now let us see, I have drawn the diagram, it's a basic diagram. So if angle A is 45 and B is 90, what can you say about angle C? Angle C also has to be 45 degree. Now what kind of triangle does this become? Now this becomes not only a right angle triangle, it also became an isosceles triangle. Now this is an isosceles right angle triangle. Now let us write down the measures of sides with relation to the angles. You know, when it is an isosceles triangles, the two sides opposite to the equal angles are equal. So now I can say BC is equal to AB. If BC is equal to AB, what can I say about AC? AC is BC square plus AB square, which is actually 2 times BC square or root 2 into BC, or this is also equal to root 2 into AB. Fine. So let us say this is x, this is x, so this is root 2 into x. Okay. Now let us start finding out the values of sin 45. What is sin 45? Sin 45 is the side opposite. Any 45 you take, it doesn't make a difference. So let us start with the original one. It is BC by AC. So let BC is x and AC is root 2x. So I will get 1 by root 2. Now what can I say about cos 45? Cos 45 is adjacent side by hypotenuse. It is the same value, 1 by root 2. So whereas 45 is concerned, sin 45 and cos 45 have the same value. Now what about tan 45? One of the most beautiful values, sin 45 by cos 45, tan 45 is a 1. If tan 45 is a 1, cot 45 will be reciprocal of tan 45, which is again 1. Cosec 45, reciprocal of sin 45, which is root 2. And sec 45 is also a root 2. So we have very easily found the trigonometric ratios of 45 degree. Now we have done the trigonometric ratios of 0 degree, 90 degree and 45 degree. Now what is pending? 30 degree and 60 degree. Now the trigonometric ratios of 30 degree and 60 degree are calculated or by drawing, or we are starting with an equilateral triangle. We are not starting with a right angle triangle. We are taking an equilateral triangle and then forming a right angle triangle inside it. So it's not very difficult to remember, just that 30, 60 are calculated on the basis of an equilateral triangle. Keep it inside your mind in case they ask you the proof. So I have an equilateral triangle over here, ABC. So each angle is a 60 degree and the sides I have taken as an x. Now, if I am dropping a perpendicular over here, let it be the point D. I can say that this triangle and this triangle are congruent. Which congruence is that? AD is a common side. AB is equal to AC, both are equal to x, and this is 90 degree because by construction I am dropping a perpendicular over there. So by RHS congruence I can say that this and this are equal. When those two sides are equal, what can I say about BD and CD? Both are equal and it is divided by x by 2. Okay. Now let us start finding out the values of sine 60, cos 60, sine 30 and cos 30. Where is a 30-degree angle? Here you have a 60, here you have a 60. But since these two triangles are congruent, I can say that this angle is equal to this angle. Corresponding parts of congruent triangles. The whole angle is a 60 degree. So this is 30 and this is also 30. Now let us start finding out the trigonometric ratios. I am starting with sine 60. Sine 60 is opposite side to angle 60 by hypotenuse. So I am taking the right angle triangle ABD. Now when I am taking sine 60, what is the opposite side? AD is the opposite side and AB is the hypotenuse. I know the value of AB, which is x, but I do not know the value of AD. In a right angle triangle, if I do not know the value of the measure of one side, what do? I apply Pythagoras theorem. So AD square is equal to AB square minus BD square. Okay. So when I am substituting it over here, I will get this. The square root of AD square will give me AD, which is root 3 by 2 into x. Now my sine 60 is AD divided by x, which is root 3 by 2. Clear? Now let us see what cos 60 is. Cos 60 is adjacent side BD by AB. So what do we get as the answer? X by 2 divided by x, which will give us 1 by 2. So the value of cos 60 is BD by AB, which is x by 2 divided by x, which is 1 by 2. Okay. Sine 60 is root 3 by 2 and cos 60 is 1 by 2. Now let us talk about sine 30 and cos 30. Now what is sine 30? Sine 30 is opposite side BD by the hypotenuse, which is the same thing, x by 2 divided by x, which will give us 1 by 2. So sine 30 is 1 by 2 and what should be cos 30? Cos 30 will be adjacent side by hypotenuse, which we have already found as root 3 by 2. Now, I hope you are clear how we have gotten the values of sine 60 and sine 30. See, we started with an equilateral triangle. So, each angle is 60 degree and all the sides were marked as x. Then we dropped a perpendicular AD over here because we need a right angle triangle. After dropping the perpendicular over here, we are suddenly having two right angle triangles. Now we need to also show that both right angle triangles are congruent. For that, we have used RHS congruence over here. After showing both right angle triangles are congruent, you can see that each angle is 30 degree because the entire angle was 60 and because the triangles are congruent, corresponding parts of congruent triangles. And you can also find the value of AD by using Pythagoras theorem. Now, because these two triangles are congruent, the whole x is divided as x by 2, x by 2. Now, for this right angle triangle, we can start with the trigonometric ratios of sine cos 60 and sine cos 30. After finding out sine and cos, you very well know how to find out tan, cosec, sec and cot. Now let us tabulate the values and see how you can remember all the values. Here you can see how I have written down the remaining trigonometric ratios of 30 and 60. So sine 30, sine 60, cos 30 and cos 60 are the values you should definitely remember. If you can remember the remaining values, it will be really great, but otherwise you can easily figure it out. Now sine 30 and cos 60, they have the same value, and sine 60 and cos 30, they have the same value. You know the reason, because in a triangle, one angle's opposite side becomes adjacent side for the other angle. That is the reason for that. So all the remaining angles I have written over here. Now let us tabulate the entire values of 0, 90, 45, 30 and 60 and these are the values that you should memorize and apply to your sums. Let us see how we can remember the values of these trigonometric ratios. So we will be talking only about sine and cos, because the remaining trigonometric ratios you can figure out from sine and cos. Okay. Now I have drawn the main angles 0, 90, 45, 30 and 60. The way you should remember is 0 and 90 are related, the starting angle and the ending angle. The middle angle stands alone and 30 and 60 are related. Okay. Now we are always starting from the beginning, which is 0 degree. The first trigonometric ratio of the first angle is always 0. We are starting from the first number, the first whole number, which is 0. So the first trigonometric ratio with the first angle is always the first whole number. Immediately you know that cos 0 is a 1. Now 0 and 90 go in pair. It is a ulta of this value. So you know that sin 90 is a 1 and cos 90 is a 0. So you are done with 0 and 90 degree. 45 degrees stands alone. It does not need anyone's help. The reason being, both the sine and the cos values of 45 are equal to each other. So you have sine 45 is equal to cos 45, which is equal to 1 by root 2. Okay. Now let us see how we can remember 30 and 60. As usual, we go from the lower angle to the higher angle. So the sine 30 is the first value we are concerned about. Sine is, so you should think like this. Sine is a very decent angle. It starts from 0 and move upwards till 1. So sine 30 has to be a value which is lesser than sine 45, which is 1 by 2. Okay, you know 30 and 60 alternate between 1 by 2 and root 3 by 2. So sine 30 being less than sine 45, it has to be 1 by 2. It cannot be root 3 by 2. So if sine 30 is 1 by 2, cos 30 has to be root 3 by 2. For 60 degree, it interchanges. Sine 60 becomes root 3 by 2 and cos 60 becomes 1 by 2. Are you guys clear with this? Pair the angle 0, 90 and 30, 60. 45 stands alone. 0 is, you start from the lower angle, which is a 0 degree angle. You start from the first trigonometric ratio and the first angle in the diagram, which is sine and 0. It gives you the value of the first whole number, which is a 0. Once you get sine 0, you immediately know cos 0 is a 1. Now, once you figure out the 0, you know that for 90 degree, it alternates. Sin 90 becomes a 1 and cos 90 becomes a 0. 45 degree stands alone because it has the added advantage of sine and cos being equal. Both are equal to 1 by root 2. In the case of 30 degree, you start with the first trigonometric ratio, which is sine, and 30 degree. Sine being a very decent angle, it starts from the lower value of 0 and moves up to 1. So it has to have a value which is lesser than 1 by root 2, which is a 1 by 2. It cannot be root 3 by 2. Root 3 by 2 is greater than 1 by root 2. Okay. So you have cos 30 is root 3 by 2. Here it is alternate. Okay. What do you understand from this particular value table? One thing you need to understand is that the value of sine as well as cos alternate between 0 and 1. The lowest value of sine is a 0 moving up to 1. The lowest value of cos is a 0, but it occurs at 90 degree. Cos 0 is the maximum value, which is a 1. So suppose while doing a sum, you are getting the value of sine of any angle as a 2 or a 2.5 or a 10. You should realize that it is completely wrong because sine value cannot cross 1 at all. Whatever be the value of your angle, 67, 63, 89, anything, it cannot cross 1. The maximum value it can have will be 1, and that will happen only at 90 degree. Any angle lower than that will have a value lesser than 1. Clear?